Okay, so this lesson, first lesson of the chapter, is going to be about the Polygon Sum Conjecture. So hopefully everybody's got their handout. The substitute should be passing that handout out at the beginning of class, and then you're watching this video, kind of going along with it. Either watching it as a whole class and kind of pausing it to do the pieces of the worksheet, or kind of doing it on your own at your pace. So you need that handout, and then we're going to be talking today about the Polygon Sum Conjecture. So the first thing here in chapter 4, we did our very first conjecture about the triangle sum conjecture, and with a triangle specifically, we remember that a triangle has always 180 degrees. So go ahead and put that down, and then we're going to go ahead and move on to other polygons. So first off, let's take a look at a quadrilateral. So what I want you to do on that quadrilateral is to go ahead and label just any of those vertices you feel like A. Then I want you to draw every possible diagonal from point A. So for this one, that would mean just that diagonal. There's no other diagonal to draw in. And so on this, you can see that splits our quadrilateral into two triangles. And if any of you put A at a different point, you're going to see it's different triangles, but it's still going to be two triangles. And since each of those triangles is 180, that's 180, that's 180, we would have a total of 360 degrees in a quadrilateral. Now you've probably seen, in a rectangle, for example, we've got 90, 90, 90, 90, 90. Well, that makes 360, but that's 360 is going to be the case for every single quadrilateral out there. But that probably makes sense. Now, what I want you to do here is to do the exact same thing with the other types of polygons listed. So our quadrilateral had two triangles, which made 360 degrees. And then so go ahead and draw a pentagon, hexagon, heptagon, and do the exact same thing. Label the vertex, draw every diagonal you can from that vertex, think about how many triangles that makes, and what the total number of degrees would have to be. So pause the video now, go ahead and do that, and then start it up again when you're ready to talk. Okay, so if we've had a pentagon, I'm just going to draw any random pentagon, label one point A, and I'll go ahead and draw in my diagonals. And you see that makes 1, 2, 3 triangles. And if I were to say, okay, there's 180 in here, 180 in here, 180 in here, that would give me a total of 540 degrees for a pentagon. If I had a hexagon, draw a hexagon real quick, and I draw in from one of the vertices, I draw in all my diagonals. You see that ends up with 1, 2, 3, 4 triangles. If they're 180 degrees each, 4 times 180 is 720. Then if I draw my heptagon, 1, 2, 3, 4, 5, 6, 7. Hard to draw a heptagon. We'll make this A, and we'll go ahead and draw 1, 2, 3, 4 diagonals, which gives me 1, 2, 3, 4, 5 triangles. And 5 times 180 is 900. Now, you can probably see a few patterns going on here. Each time we add a side, we are increasing the number of degrees by 180, but we want a formula for this. And so thinking back to what we did in chapter 2 when we were coming up with these formulas, look for a connection from here to here. You can see a pattern between the number of sides and the number of triangles. Right? There's always 2 less, so we'll have n minus 2. And then to find the number of degrees, or the sum of the measures of the angles, since each of those triangles is 180, we're just going to take that answer times 180. So our formula we're going to use is 180 times n minus 2. Now that is something you definitely want to be writing down in your conjecture packet. So the sum of the measures of the n interior angles of an n-gon is 180 times n minus 2. Or you could write it as n minus 2 times 180. Either way is fine with me, but take a second and put that into your formula, or not your formula sheet, your conjecture packet, that gold packet. Okay, so hopefully you have that added. The next thing I want to look at is the formula for finding each interior angle of a regular polygon. And so the big thing here, if you look down at these examples, a regular polygon is one where all of the sides, and more importantly, all of the angles are equal. And so if you've got a pentagon, for example, and you find the total using my formula n minus 2 times 180, the way that I can find each one, if they're all equal, is just divide by n. So for a pentagon, 5 minus 2 times 180 is 540, divided by 2, I think, is 72. Now, some of those do come out to decimals, just be aware of that. So any regular polygon, if I want to find each interior angle, since all the angles are the same, I can just do 180 times n minus 2 divided by n. Now, I will leave that up to you whether you want to put that in your conjecture packet. If you know the first one and you remember what the word regular means, there's no reason to have an extra conjecture for this one. But it is something we want to point out that's how you could use that. Finally, take a look at this picture here. I'm going to say pause this video for 5 minutes or so. Let everybody get a chance to work, and then I'll go over it when you restart the video. Okay, so if I'm looking at this, the thing we've talked about with these kind of pictures is always find what you can first. So first thing I'm looking at is actually angle B, because I know that those two angles have to add up to 180. So I'll grab my calculator and do 180 minus 72, and I get 108. And I'm just going to write that right in 108. Now I've got a pentagon. Well, I know a pentagon has 5 sides, so 5 minus 2 times 180 is 540. So I know that the total degrees for this whole pentagon on the interior angles has to be 540. So now I'm just going to subtract. I got 90 here. I've got 120 here. This one's marked congruent, so it's also 120. So I'm going to do 540 minus 108 minus 90 minus 120 and minus 120. When I hit enter on my calculator, A comes out to be 102 degrees. So A is 102, B is 108. And so the big thing here is the number of angles or number of degrees total inside of a polygon is going to be found with that formula. Then you can use vertical angles, linear pairs, and the sum to find out whatever's missing. So what you've got for homework here, page 264, numbers 1 through 4. The back side of that sheet of paper is empty, so feel free to do it on that, or just grab a sheet of notebook paper, whichever one you would prefer. If you are having any questions, a good place to go online is to look at Khan Academy and see any of their videos. But also feel free to, work with one or another person in the class. Pair up and work together on these. As long as you're being quiet, that is fine with me. And I will see you tomorrow.